Yes, Tom, you've been very patient. Tom received a bachelor degree in psychology from the University of California, Santa Barbara, wonderful place, a master's degree in research psychology from California State University at Long Beach, all the prime places. All you need is Santa Cruz and you've got a trifecta. Yeah. And a PhD in social psychology from UC Southern California. Research interests on the causes and consequences of anger and aggression in humans. Tom, would you please speak to us?
Thank you. Thank you. I should also say I'm currently at the University of New South Wales. Been there for the past 4 years almost. Okay, so today I want to talk about what happens in the brain when we get angry, and that's sort of a descriptive study. And then I want to talk about how we can use that knowledge about how the brain works when we're angry to test a couple of little interventions that we've done with some experiments with young people at the University of New South Wales. So this applies to sort of 18 to 20-year-old students primarily. That's our population that we're working with. And I want to say thank you. None of this work gets done. I'll do it myself. I've got lots of great people that have helped me out. And I also want to thank the Australian Research Council and the NHMRC for supporting some of this. And of course, all of the hundreds of participants from UNSW that have been in the studies. Okay, so this starts out with a little audience participation. So I'm going to give you an aggression test. And it's not going to look like an aggression test, but trust me, it is. And it only works well if it's done at high volume. That's actually not true. I made that up, but it's more fun if it's done at high volume. So as loud as you can, read the word that appears. Green. Awesome. Red. Blue. So far, so good. All right, now say the color that appears below.
Red. Blue. Green.
So far, so good. Perfect scores, high marks, HDs all around. Now say the color that the word is written in, as loud as you can.
Green. Blue. Red.
Ah, what a train wreck. Why is that so hard? Your brain is going, oh, that hurts. That's hard. Why? Because we see words, the automatic impulse that we have is to read them, right? This is called the Stroop task. This is from 1935. It's an ancient task, but it's really good. It's a good measure of inhibition, inhibitory control. Now, your automatic impulse is to read green, is to read the word green, right? But I've asked you to do something else, which is say what color that is, and that's an incompatible response. So your brain has to wake up, say, hey, dummy, don't say green, say red. Okay, so take control of the situation. Now, it turns out that this little area is important. This dorsal, it's called the dorsal anterior cingulate cortex. I know that's a mouthful. I'm going to refer to it as the DACC. You can call it whatever you want, the teddy bear if you like, whatever. I'll call it the DACC. And that little region is active when people do the Stroop task. And what it does is it monitors for discrepancies in the environment. Okay? So you had this automatic impulse, but then suddenly you've got to do something that requires controlled processing, okay, which is override the automatic impulse and kick in the controlled processing. And that's what this little wonderful region does in normal people. All these other regions that are highlighted here, this is from a review article by Adrian Rain, and these are differences in sort of the people that Andrew are working with, the real sort of hardcore cases. But what I want to talk about is just normal people, and this happens in normal people when they do the Stroop task or whatever, right? So that's the idea. It's called the neural alarm system. And the reason it's called the neural alarm system because just like an alarm clock, it's sort of whirring away in the background, and then something comes to your attention that you need controlled processing to do, and it wakes up the rest of your brain, the parts of the brain that are involved in controlled processing. Okay? So primarily the rest of this prefrontal cortex, which is more recently evolved in humans, and it supports all of the functions that make us sort of uniquely human. It lets us plan our activities, take control of our behavior, plan for retirement and superannuation and all those great things, right? Think about future consequences of stuff, all of that stuff. So it activates those regions. So it's this mediator between unconscious or impulsive processes and more controlled or conscious processes. So it recruits these other regions that are involved in controlling our emotions and our behavior. So it's a pretty nifty little region. Now, I'll talk about study 1. So why is that relevant to aggression? Well, we think the DACC plays a particular role in controlling aggressive impulses, right? So in this first study, we had people come in to the lab, and we had them fill out what's called this aggression questionnaire, and it was embedded in lots of different questionnaires, so people didn't know we were looking at aggression specifically. And these are some questions like, if somebody hits me, I hit back, and people can rate them on very uncharacteristic of me to very characteristic of me. I tell my friends openly when I disagree with them, right? So some people are going to rate themselves a little bit higher than others on this, and those are the people we're interested in. So just sort of run-of-the-mill university students who tend to get into fights more often than the average university student, right? And then we had them come back 2 weeks later, and they came in for a scanning session and an MRI scanner. And we use a type of MRI called functional MRI, and that's where we can see changes in blood flow associated with different mental states or tasks. So what we had them do at the beginning was they came in and we presented them. They're lying down in the scanner, and they can see the screen, and they're presented with difficult anagrams, and their job is to say the answer to the anagram if they know it, or to say no answer if they don't know it. Does anyone know what this is? Anyone? Environment, yes. You need to get to Mensa quickly. It's an IQ test. That's amazing. So they're like this. They're very hard, lots of vowels, very difficult. Okay. So the first minute goes by. They get Friendly Tom. Friendly Tom says, look, I can barely hear you. I need you to speak louder. I'm in the control room talking to them on the microphone. Another minute goes by. They still get Friendly Tom. Friendly Tom says, hey, I can barely hear you. Please speak up. Third minute goes by. They get Angry Tom. Angry Tom says, look, this is the third time I've had to say this. Can't you follow directions? Right? So I make them feel like little children, right? And this makes people mad. How do we know? Well, we ask them later. This is when they came in. They weren't very mad. They weren't very angry. Afterwards, quite angry. But that wasn't what we were really interested in. We know this works from other studies. What we really wanted to know is what happens in the brain. And here we see our dorsal anterior cingulate cortex lights up, if you will. It becomes more active following the provocation. Okay? And not only that, it's correlated with their scores on that aggression measure. So the people who were more aggressive reported being higher in aggressive personality, getting into fights more often. They showed more activation in this region. And the angrier people were. The angrier people reported being, they also showed more activation in this region. What does that mean? Well, aggressive people and angry people, they needed more recruitment of top-down control. So this region is firing away, and it's shooting off to other regions of the brain saying, help, hey, wake up. I need you to help me control this. I'm really angry right now, right? So that's what's happening. And it was particularly specific. We asked a lot of other emotions, and it was specific to anger in this case. Whoops. So the bottom line there is that controlling aggressive impulses and anger is hard work for some people, right? People that tend to be higher in aggressive personality. Now, how can we use that knowledge to sort of test anger-reducing interventions, if you will? So the first thing we did is we know that the brain runs on glucose, right? Sugar. So if people who are high in aggressive personality are using more energy, right, to control their anger, we thought, well, let's try giving people sugar, right? A bunch of sugar. And that's what we did. Make sure they have enough fuel available to control their aggressive impulses. So we had 170 students. Again, they completed that aggression questionnaire. Half of the people were insulted. The other half were not. And they were insulted by another participant. So they thought it was all set up, but they thought they were being insulted by another participant. They gave a little speech about their life goals, and the other participant in a pre-recorded statement said, you know, your life goals are really stupid. You haven't thought about it. It's a waste of my time listening to you, right? Good times all around. It's a double-blind study, so the experimenter didn't know what drink they were giving them, right? And the participant didn't know. We told everyone that everyone's getting sugar, okay? And then we measured aggressive behavior. I'll show you how we measured that in a moment right now. So that's Coddy's. We didn't get any funding from them, but we did use it because it's a disgustingly sweet drink. So they got about 50 grams of sugar, and we didn't dilute it like you're supposed to, right? So we gave them a real hardcore sugar shot. And we gave them enough time to metabolize the sugar, right? And then they were insulted. Okay, so their job here, this is what they see. They get to select how long and how loud the other person should be blasted with white noise. So essentially they've got a weapon here that they can use against the other person. And it's a game. It's all under the ruse of a reaction time game. So they get this yellow box, get ready, click the mouse, boom, when it turns red, react, okay? They click the mouse. It says you win or lose. If they win, they get to blast the other person. We rig it so everyone wins, right? Okay, so they've essentially got this white noise blasting weapon they can use. That's our DV. Now, what do we see? Well, when people were not angered, the glucose or the placebo, it didn't matter, okay? It didn't matter which drink they got. But when people were angered, you see here that people who were given the glucose were much less aggressive than people who were given the placebo, right? So it gave them a little bit more energy. And that's specific to people who are high on this trait aggression. Let me show you that in a minute. So if we just look at these people, just the provoked people now, we see here if you're low in aggressive personality and you've been angered, you've been insulted by this other student, but you're not an aggressive person, you never get into fights, it doesn't matter which drink you got, right? You're not aggressive anyway. Very low levels of aggression. However, when you are high in aggressive personality, you're this person that tends to get into fights more. If you're given the sugar, now suddenly you're about just as aggressive as if you're low in aggressive personality, right? So it's a big reduction there. And again, this is the sort of control condition. They're given the placebo. They're highly aggressive people. They've been angered. They're topping out at 10, right? They're topping out on this noise blast task, right? Okay, so that's pretty good evidence showing that if you give aggressive people the energy that their brain requires to control their aggressive behavior, they can do it, right? And then they do it. Okay, so the second one is, how about practicing self-control, right? So if we had you do lots and lots of trials of that Stroop task, you'd get pretty good at it, right? So that's exercising this DACC, right? Like a muscle. You can exercise and get stronger. That's the idea. If you exercise this muscle, it'll get stronger, and that should translate then to reduced aggression. So what we had here is we had 70 students. Again, they completed the trait aggression questionnaire. We gave them instructions. We had 2 conditions. We had a self-control training condition, and in that condition, we asked people to use their non-dominant hand. So if they're right-handed, they use their left hand to do everyday tasks that were reasonably safe. So we didn't ask them to chop vegetables with their other hand, but use the mouse, open doors, stir coffee, answer the phone, right? Everything with your non-dominant hand. And no one does it perfectly, and that's actually what's important about it, right? Because you catch yourself. It's just like doing that Stroop task, right? You catch yourself, and you say, oh, crap, I went to open the door with my right hand. Use the left hand. So you're practicing self-control. You're overriding that impulse, which is to use your right hand, and overriding it now to use the left hand, right? So you're practicing that. So your DACC is happy, it's getting a workout, right? Good times all around. Now, in the math condition, that was just a control condition that other people have used in literature. We asked them to solve simple math problems, okay? So they're doing some sort of mental effort, but it's not related to self-control. And then they came back 2 weeks later, and we did the insult where they were insulted, provoked by another participant. And then we measured aggressive behavior, again with the blasts of white noise. And what do you see? So if people are low in aggressive personality, they're not very aggressive. But if you see here, people who got the self-control training, people who practiced using their non-dominant hand for 2 weeks, they're much less aggressive than people who just did the math, right? If they were high in aggressive personality. So again, this applies only to these people that say, yeah, I tend to get into fights a lot, right? So practicing self-control was good for them. Presumably, it brought their sort of brain functioning up to the level of less aggressive people, right? That's the idea there. Okay, so just to summarize, the dorsal anterior cingulate plays a critical role in controlling anger and aggression. And I don't want to imply that this is an anger region. It's a control region. It's related to self-control broadly, right? So it's things as mundane as the Stroop task to do you punch someone in the face, right? It's involved in control. And controlling anger-driven aggression is hard work for some, normal people. And increasing the fuel available to the brain via glucose or practicing self-control can help aggressive people control themselves. Obviously, lots more research needs to be done, and I have no idea if it'll apply to these hardened criminals or troubled boys. But at least in regular sort of university students, it seems to be pretty effective. So that's that. Thanks.
Thank you. Tom, as you were telling that story about your students and those experiments, I was reminded of something I broadcast a few weeks ago in a program on 4 of the greatest stuff-ups in science. And it's a story that started the program. It's about an experiment at Harvard where they were trying to work out what the Koreans did in brainwashing, and a particular professor did a number of things with students which began by asking them, what's the most horrible thing you could imagine happening to you? And then he exploited that knowledge by making it come true in some ways. And the end of the story is that some of the students seem to have a particularly bad experience. But one in particular, a brilliant mathematician, left Harvard and became the Unabomber. You know that story?
Yeah, no, I'm sorry. I should have clarified at the end of the experimental session, we debrief everyone and make sure that everyone leaves in a good mood.
I'm sure you do.
It's all, there's an ethics process. It's not all fun and games.
When I wander around the University of New South Wales, these guys chucking bombs at me.
No.
No, I'm sure that that's exactly the case. But you ended up by saying you didn't know how much it would have a practical kind of effect on the people in the field.
I think practical and sort of it appears very promising for sort of run-of-the-mill, sort of everyday kinds of aggressive behavior. You know, it might help you hold your tongue in a meeting with your boss, or you know, if you have a problematic boss and you drink a sugary beverage before you go in, and you're an aggressive person, right? You've got that's the key.
No, I was wondering more globally about the links between the neuroscience that you're doing and the practical talking therapy that your colleagues are doing.
Yeah.
Are they beginning to meet up, these two fields?
I don't know. I mean, you guys would know. My sense is yes, to some extent.
I was really interested in what Tom was talking about, because the model in anger management programs is a model where cognition mediates between emotional arousal and behaviour. So a lot of the things we talk about in programs are about beliefs and interpretations and perceptions of social events. There is a school of thought in anger that cognition isn't as central to anger arousal and anger expression as people have tended to think, and has formed the basis. And it's a little bit like Michael's stuff. It's about the experience and using the drums or the percussion to experience emotion rather than intellectualise, which is what psychologists love doing, but is often a downfall, really, because often the clients we work with who are angry aren't good at intellectualising. They don't have a lot of insight and they don't want to put language to their problems in that way. So I think there is a lot of possibility in the next few years for these kind of streams of thinking to come together.
What about sugar in the practical sense? Do you think that kind of boost can be applied?
Yeah, I mean, I think, as part of a well-rounded diet, right? We don't want to load everyone up on sugar, but for certain people who have trouble, you know, the example I always give is if you know you're going into a meeting and you know your boss is going to annoy you, and you're an aggressive person, then a little bit of sugar might go a long way, right? But I think in terms of more practical things, the self-control training, that could be applied to any of these, you know, anger management techniques. It's not hard to do. It's cheap, you know. It doesn't require a lot of mental effort, right?
And what do the students say after the experiments?
Yeah, I think most of them actually quite enjoy it. You know, and they are. They're helping us learn more about these phenomena. So.
Are they psychology students? Or
yeah, most of them are.
I see.
Yeah.
Right.
Yeah, so they're interested. Anyway.
So they're second guessing what you're doing?
Sometimes, yeah.
Is that a disadvantage?
There's a few every year. We try to get them early on in the first year of psychology, so before they learn too much. Yeah.
Yeah, well, it's the great source of cheap labour. Yeah, I was just wondering whether also the ideas of evolutionary psychology might apply, because you often wonder, what are these things doing so commonly in the population? Because many of the problems we have, such as depression or even schizophrenia, 1 in 100, that's a huge number. And then you look at what might be the case with depression. It's an extreme adaptation, some people suggest, to deferring to the leader in the village or in the tribe. You know, it had a function where you kind of behaved. And if you make it extreme in a kind of society we're in today, then it comes out as a kind of clinical thing. Is anger a similar sort of metaphor in that way?
Yeah, I mean, I think if we want to go back to the hunter-gatherer days when there was no law enforcement, right? I mean, anger was very adaptive in protecting yourself, protecting your family, even proactively obtaining resources from someone else, right? So I'm pretty sure the reason all of us are here today is because one of our ancestors was pretty mean, right? At some point.